Hey guys, in this video we'll be going through the steps to set up an AWS environment from scratch and deploying a .NET Core API to AWS Lambda that connects to a database running on AWS RDS and sends email via AWS SES. The API that we'll be using is a boilerplate example that I posted a little while ago. We won't be digging into the code in this video, but you can find the full documentation available at this link here. The API supports email registration and authentication functionality, and we'll be testing the registration functionality in this video just to test out that everything that we've deployed has worked. Today we'll be going through the tutorial that you can see on your screen now that I'll link to in the video description below. These are all the steps that we're going to cover. There's quite a lot that we'll be covering today, so I'll try to move through the steps quite quickly. If there's any detail about any one of the steps that you're not sure about or that you have some questions about, just jump back over to the tutorial, and there's extra information and links regarding each step along with the instructions for each one of them and screenshots. Okay, so let's get started. First thing we want to do is create our AWS VPC. So jumping over to the AWS console. If you don't have an account yet, you can create one. I already have one, so I'll just need to log back in. And then go to the VPC section. You can access any of the sections in AWS by using the search box. Go over to your VPCs and select Create VPC. Enter a name. Just enter my VPC for this one, and enter a CIDR block for the VPC. The CIDR block defines the IP address ranges that are available to the resources that you create within your VPC. If you're not sure what to put in there, you can just use 10.0.0.0/16, and that means the addresses from 10.0.0.0 up to 10.0.255.255 are available to the resources in your VPC. There's also extra information available at this blog post at DigitalOcean that provides a lot of information about how IPv4 CIDR blocks work. Okay, you can leave the other things as default and click Create VPC. The next thing we need to do here is enable DNS host names for our VPC. This is required for this example because we'll need to enable external access from our local machine to our SQL database that we'll be creating a bit later in order to initialize the database. So hit Save Changes there. And then moving on to the next step. All right, creating the subnets. We're going to create 2 public and 2 private subnets. Our SQL server is going to be running in the public subnets in order for us to connect to it to initialize the database from our local machine using entity framework migrations. And our Lambda function is going to be running in our private subnets. So jumping back over to, so these are the instructions for all the details to enter for our 2 private and 2 public subnets. We want the public subnets and the private subnets to cover 2 availability zones each. So jumping back to the console, go to Subnets and select Create Subnet. Select our VPC from the drop-down list. You can click Add New Subnet until you have 4 forms there, and then enter the details. So I'll start with public subnet 1. I'll put that in the first AZ for my region and enter a CIDR block that fits within the range of your VPC CIDR block. So I'll enter that one for here. Then public subnet 2, and I'll select the second AZ for public subnet 2, so it's different from public subnet 1. So the public subnets cover 2 availability zones, and that is a requirement for our database that we'll be creating later, that it covers multiple AZs. Next, let's create private subnet 1. We can put that in the first AZ. And the CIDR blocks, I'm just incrementing by 1 for each subnet. And private subnet 2. And I'll put that in a different AZ to private subnet 1 as well. And use the next CIDR block for that. And click Create Subnet. Try that again. Oh, no, I've missed. No, I've got an overlapping CIDR block. Okay, public subnet 1. Okay, that needs to be 2 and 3. Okay, now click Create Subnets. Okay, those are done. Moving on. Next, we'll create the Internet Gateway, which will enable internet access to and from our VPC. So I'll create the Internet Gateway and attach it to our VPC. So go to Internet Gateways, create Internet Gateway, give it a name, and select Actions, Attach to VPC, select the VPC we've just created, and attach. And that's it. And then jumping down, we'll create a NAT Gateway. So the NAT Gateway is used to enable outbound internet access for resources in private subnets. So jumping over to the NAT Gateways section, click Create NAT Gateway and give that a name. NAT Gateway has to live in a public subnet. And requires an elastic IP. So I'll allocate one there. Click Create NAT Gateway. And then moving on to the next step. Okay, next we'll configure the route table. So we have a default route table for our VPC, which is used for any subnets that don't have a route table explicitly associated with it. We'll make it so our default route table is configured for private subnets. So any new subnets that we create are private by default. And then afterwards we'll create a second route table for public subnets. So going up to the route tables section, we'll create, so there's the main route table, the default route table for our VPC. Select Edit, I'll name it main route table so it's easier to identify in the list. Select Routes, Edit Routes, and then we'll add a route to route all traffic to the NAT gateway that we've created. Select that and save. Okay, next we will create a new route table for our public subnets. So going back to route tables and create route table. We'll call this one public route table and select our VPC, create, and we want the routes in this route table to go to the internet gateway to make it public. So we select add route, route all traffic through the internet gateway, and select save. Then go to subnet associations and edit subnet associations and select the two public subnets and click Save Associations. And so that association with the public subnets is what actually makes those subnets public. So now any resources created in those public subnets will have their traffic routed via the internet gateway. Okay, moving on. Next, we'll configure the default security group for our VPC to allow traffic from our local machine through. And that is also, for what I mentioned before, initializing our SQL database when we create it for the API. So going to the first, let's double check our VPC ID. Starts with a 061. So we need to know that because in the security groups section you can't see the VPC name, so we know that 061 is our VPC, so this is the security group we want to edit. We'll edit the inbound rules, add a rule to allow all traffic from my IP, and that will allow us to initialize our database a bit later. Okay, that was the last step for setting up the AWS environment. So VPC, subnets, internet gateway, NAT gateway, and security group, everything's configured. Next, we'll create our SQL Server database in RDS. So jump over to the RDS section. And select databases. First, actually, we need to go to subnet groups. We need to create a subnet group for our database to ensure that the database gets created in the public subnets of the VPC. So we'll call it public subnets. Choose a VPC, select the availability zones where our subnets are created, and we can't see the subnet names here, but I know that I created the first two subnets I created were the public subnets, so I can tell from the CIDR blocks here that the one with the 0 and the one with the 1 are the two public subnets. So I'll select those two, click create. So now I have this DB subnet group, and any databases created in there will be in the public subnets of the VPC. Now going to databases, select create database. Leave it as standard create at the top, select SQL Server. Leave Express Edition. Select the last major version. You need to do this, I found, to get this templates option to appear, which has the free tier option. You can leave the database identifier as database1, username as admin. I'll select to auto-generate the password. DB instance class you can leave as default, same with storage. Connectivity, you can see the subnet group selected is the public subnets that we just created. We want to enable public access so we can initialize the database. And everything else we can leave as default. Select create database. And while that is creating, let's jump over to the next. Oh, actually, I always forget this important step. Because we auto-generated the password, we need to view the credential details and make a copy of that password now. I'll put that in a notepad file because we'll need it when we're configuring the API a bit later. Okay, next step is configuring email in AWS SES. Now, to send email via AWS SES, you need to verify your sender addresses. And when you first set up AWS SES, it's in what's called sandbox mode, which means that you have to verify both sender and recipient addresses when you're in sandbox mode. That's the mode that I'm in with this account. So I will need to verify 2 email addresses because we'll want one email address verified for to be the sender for the API to be sending from, and another email address that we're going to use when we're testing the API to register an account with the API, and that'll be the recipient address. So jumping over to email addresses and verify new address. So rather than having to use your own addresses and verify them in there, you can use this other service that I found a little while ago called tempmail.org, and it allows you to use temporary disposable email addresses. I'll just open that up in a Firefox private browser so it doesn't show the annoying ads. And there's a temporary email address for us to use. I'll copy that. There's the inbox displayed below. Going back to the AWS console, I'll paste that address in there. Click verify this address. Okay, it says it's sent a verification email to me, and it shows the status as pending verification. So if I go back to the inbox, there's the verification email, and it contains a link to verify that address. So I can copy that there, open a new tab and paste. And that shows that our email address has been verified. So if I go back to the SES console here and refresh, shows that the address has been verified. Next, I want to verify a second address. So to do that, this one I'll use as the sender address from the API, so I don't need to hold on to the inbox for that. I'll hit delete here, and that will cause tempmail to generate a new address for me. So this one I'll use as the recipient address when we test the API. So I'll click verify there and go through the same steps as I did for the first address. There's the verification email. Copy that link, paste into a new tab. And that email should be verified as well now. Alright, that's all done. The next step is to get our SMTP credentials that the API is going to use to connect to AWS SES and send email via SMTP. So we'll create a username and password for sending email via SMTP. The way to do that is go to SMTP settings in the SES section and simply click create my SMTP credentials. Then click create and show user SMTP credentials. There's our username and password. I'll make a copy of that and paste it in my notepad file to use later when configuring the API. Okay, up next we'll create the Lambda function that will actually hold our .NET Core API. Just before doing that, we'll need to create a role in the IAM, or Identity and Access Management section of AWS to enable the Lambda permissions to execute within our VPC. So within the IAM section, go to Roles, Create Role, leave it as AWS Service, click Lambda and Next. And this is the policy that we want to attach to the role. So filter the policies by that. Tick that there, click Next. Then Review. And then enter a role name, call it my Lambda execution role, and create role. Then go to the Lambda section, select create function. We'll call this one my .NET Lambda. Select .NET Core 3.1 as the runtime. We'll change the execution role to use the role we just created. And under advanced settings, we'll select our VPC for it to run in. We want it to run within our private subnets. And we'll use the default VPC security group. Select create function. Alright, and that is creating now. So next, we'll create a HTTP API in the API Gateway section, and that's what actually enables external HTTP requests to actually reach to invoke the Lambda function. So go to the API Gateway section. Select build under HTTP API. We'll add a Lambda integration. We'll select the Lambda function we've just created. For API name, we'll just enter my HTTP API. And next, the resource path will change to a proxy path, so it proxies all our requests straight through to the Lambda function. I'll copy that here. And leave it as any method and the integration target as the Lambda function. Next, leave the stage name as default. Next, and create. Okay, that's done. Next. Okay, now we'll actually download and update the .NET Core boilerplate API so it can run on AWS Lambda. By default, it's set up to run locally, but not on Lambda. So there's a few little changes that we'll make. So jumping over to the GitHub repo, I'll copy the Git URL there, and I'll clone it from the command line. So git clone, and cd into the project folder, and then open it in whatever your preferred code editor is. I'm using VS Code. Okay, there's all the code for the boilerplate project. Let's see what the next step is. Alright, the boilerplate project runs with SQLite by default. We want to change that to use SQL Server to connect to the one that we've got running in AWS. So first we'll change the package that's in the CS proj file from SQLite to SQL Server. So over here we've got a SQLite package for Entity Framework Core. Change that to SQL Server and save. And then restore all the packages from VS Code. I can just click this button here and that will restore all the NuGet packages for the project. Next, we want to update the Entity Framework data context file to use SQL Server, server instead of SQLite. So I'll just copy this section here and go over to the data context file and change this from SQLite to SQL Server and save. Next we'll change the database migration files, or the Entity Framework migration files, from SQLite, which they are at the moment, and we'll generate some for SQL Server. So going to the migrations folder here, we'll delete these because they are for a SQLite database. And then using the EF Core tools for the .NET CLI, we can run this command to generate new migration files for SQL Server. If you don't have EF Core tools installed yet, you can run this command here, and that'll install the EF Core tools for the .NET CLI. Once you've got it installed, run that command, and that will generate the migration files. Okay, so we should see those in there now. Yep. And we can see here that it's for SQL Server. The next step is to update our database connection string within the app settings file. So app settings is down here. At the moment, database connection string is for a local SQLite database. So I'll delete that and I'll replace it with this format for SQL Server, and we'll get the DB server URL from the AWS console. So going over to the RDS section, and our database should be finished creating now, so it should have a endpoint URL. The DB instances, there's the endpoint. Copy that and paste that there. The DB name can be anything you like. I'll just call it my database. The username is admin from when we created the database earlier, and the password is the master password we copied into the notepad file. So copy that, paste that there, and save. Next, we'll update the SMTP config to, for the API to connect to AWS SES and send email. So we can see the SMTP config here. First, I'll update the email from address to use the address that we verified earlier. So jumping over to the SES section, and email addresses. And I know this is the recipient email address that we're going to be using, so it'll be the other address that we use for the sender. So I'll copy that there and paste that there. Next, the SMTP host. We can find that over here under SMTP settings, and that's the server name. So copy that there, paste that there. You can leave the port as 587, and the username and password are the ones that we copied before from the SMTP credentials that we created. So copy that username and that password and save. Finally, we'll update the API to actually support running as an AWS Lambda function. First, let's add the NuGet package, Amazon Lambda aspnetcore server, by running this command. Okay, and next we'll create a file called lambda entrypoint.cs in the root folder of the project. And this will be used by Lambda as the entry point into the API. So a new file, lambda entry point, and you can copy this code here. You can see that that Amazon Lambda ASP.NET Core server package is used there. And save. Alright, that's our API updated. So it now supports running in Lambda. The next step is to deploy the API to Lambda. Actually, before we do that, we need to initialize our database that's running up in Amazon RDS. So to do that, we'll run our database migrations against our SQL server that's running in RDS. And to do that, we'll run this command, .NET EF database update. Okay, those migrations were done, so our database in RDS has been initialized. Next, we'll install the AWS Lambda extensions for the .NET CLI, and those tools, the extensions will enable us to run a command that will package up the API as a zip file that we can upload to the Lambda function. So to install those tools, you run this command. I already have them installed on my machine, so once you have them installed, run this command to package up the API. Okay, so you can see that's been done, and the package that's ready to upload to Lambda is located in that directory. Next, let's jump over to the Lambda function and actually upload our API package. I go to the Lambda function, select upload from zip file, click upload, and select the package you've just created and save. Alright, once that's uploaded, there's just one more step here, which is to update the handler in the configuration of the Lambda function to point to the Lambda entry point that we added to the project. So make a copy of that there, and under runtime settings, click edit and set the handler to point to our Lambda entry point and save. Okay, that's our API deployed. Next, we want to test the API with Postman. If you don't have Postman installed, you can download it here. And then follow along with these steps. I'll open it up now. Okay, open up a new tab. Set the request method to post. The request that we're going to be making is to register a new user with our API, and what that's going to do is going to test all of the pieces that we've deployed and set up, because it's going to create, it'll make a request to the Lambda function. The Lambda function is going to create a new account in the SQL database and also send a verification email to our verified email address via SES. So we need to get the invoke URL for our API, which we get out of the API Gateway section from the HTTP API we created. Go to HTTP API, make a copy of that invoke URL. We'll go back to Postman, paste that there, and we want to use the accounts/register route. Set the body to raw and JSON type. And back in the post, these are the parameters to register an account, so I'll make a copy of those. And we just need to update the recipient or the registration email address to the one that we've verified. So going back to the verified email, make a copy of that. Paste that there and send. So if we did everything right, we should get a message saying registration successful. Okay, great. So it says registration successful, which means our account has been created in the SQL Server database, and we should also have an email in our temporary mail inbox. And there it is. From the sign up verification API, we have our verification email. Alright, so that's everything working. So that is all the steps to set up an AWS environment from scratch and deploy a .NET Core API to AWS Lambda with a SQL Server database in RDS and sending email by AWS SES. There's one final step that's in this tutorial, which I won't cover in the video, but you can go through it to avoid incurring unnecessary costs for resources that you're not using anymore in AWS. But this just goes through removing everything and cleaning up everything that we created within AWS. So you can follow these steps to delete all the stuff that we just created. But yeah, you can just follow these yourself. I won't waste your time with them in the video. But yeah, that's everything. So hope you enjoyed the video. Thanks for watching. Cheers.